So as most of you know, this is part of a series of bi-monthly demonstration sessions where the development team at Naturalis wants to show the progress with the things that they are doing with focus on the work in work package 3 and the DiSSCo Transition phase projects. But also we will mention the progress in other things that the team is working on. So this session is is focused on the minimum viable products that needs to be delivered at the end of the DTP projects. So that is a minimum viable product of the DiSSCo specimen data infrastructure. We will also touch on BiCIKL and TETTRIs projects. The team will report and demonstrate what has been done so far, but also have a look towards the future. And there will be room for discussion. So we would like to get feedback on the progress and the plans in this meeting. And the meeting will be shared through our DiSSCo Tech blog, so that people can watch the recording later. Next slides.
Yep.
So I first would like to tell a little bit about the BiCIKL results, the work that we have done for DiSSCo in BiCIKL, because that project is nearly finished. It will finish at the end of this month. We developed PIT infrastructure and digital specimen repository components in the projects. So this forms the basis of the further development of the MVP in DiSSCo Transition project. We have also demonstrated linking from the digital specimens to other infrastructures in the project, and we have minted the first digital specimen DOIs and are working on a publication that demonstrates the first use of these DOIs. That publication is about spiders. It's in preparation in the Biodiversity Data Journal. It's a revision of 2 spider genera and a new species description. And it uses the digital specimen DOIs to identify the specimens and also nano publications. We link the digital specimen DOI in the material citations through Darwin Core order catalog number, because we thought that is the best fit currently in Darwin Core. Although I think we will need a new Darwin Core field to properly identify this. One issue with this one is that it is part of the occurrence class in Darwin Core and not of the record basis class. Benefit of using these nanopubs with the publication is that we can say something like the digital specimen DOI is discussed in this article, which was published on that date by this and this author. And that would allow easy tracking of specimens that are cited in publications and by whom these specimens have been cited. So the usage of specimens would then be very easy to track. After we have finished the publication, which will probably be this week or maybe next week, Pensoft will work on adapting the ARVA platform to integrate the templates that we have created for the nano publications within the platform, but also to show a tooltip for the digital specimen DOIs, and it will look like something like I displayed here. And that makes use of the metadata that we supply within the DOI record. So that if you go over a digital specimen DOI, you immediately see some context about that DOI. You see some metadata. You see the catalog number with the link to the catalog if available. You see who is hosting the specimen. You see a name for the specimen, and you can go to the DiSSCo specimen by clicking that name. Okay, that is what I would like to, what I wanted to tell about the BiCIKL results. We are currently working on finalizing the final deliverable, and that's almost done. Next slides. We'll now hand over to Sam.
Yeah, this is just a reminder slide on what we're doing with the data providers. I think most people have already seen this, so I'll go through this quickly. So we're focusing in our team mostly on these components. So what's new? That's more fun. Actually, the slide got bigger and bigger. I need to scale down a bit. The first part is actually a continuation of what Wouter mentioned. So we have minted our first DOIs, which we're really happy with. Actually, Wouter mentioned the FDO metadata. So this is one of the records, and then this is the FDO record. So these are all the attributes that this specimen has and that are now being used by the tooltip to get this the information out. This is still, we did most of this manually, so was a bit of work, but the infrastructure was there, and so we have a small DOI infrastructure now in kind of production state, running as a production service. The DOI redirects to the sandbox environment because we don't have a production environment for specimen yet. So this is the specimen in the sandbox environment, and we put a bit more effort in it to get the data all right. So the taxonomy is there and all the other things, but we also included the relationships. So now you slowly see this graph growing with links to all kinds of other infrastructures. So of course we have the FDO record going to the TTR. Is it the data type registry? We have organization going to RLR. We have now included the category of life identifier going to the taxonomic information. Well, how all the taxonomies build up. And we also have in this case, two recorders of the specimen, which go to Wikidata. So you now have links to all these other infrastructures. And it's a nice example where you actually see this cloud growing, and if we get more infrastructures connected. So now this specimen is still relatively new, but if DNA goes in ENA, then we can create a link to ENA. If it goes into GBIF, we can create a link to GBIF. That's how this cloud of connected information will grow. Last time I talked about the integration with DataSite, and let's grab, this is in the way. Let's see if I can move it here. And I showed this image of how we would connect to DataSite. So DataSite, we had issues with the DataSite API because the performance wasn't that great. And I needed a lot of changes to make the FDO record to be able to handle the whole FDO record. So in the end, we decided that for the time being, we would be hosting our own local handle server storage, our own DOI manager, our own local handle server. So this is actually served, this information is actually served through a local handle server and in storage that we host, that's in our domain. And then we would then start pushing to the DataSite API asynchronously. So we will be ingesting by a couple hundred a second, and then we will get some queue here because the DataSite API can handle about 3 or 4 a second. So yeah, that will take a while before everything is pushed to DataSite, but in the end, we'll get this synchronization. So it's eventual consistency between basically these two data storage sets. Yeah, we have discussed this and tested this and created this handle pusher, which also translates our FDO attributes to the DataSite attributes. So there's also a bit of translation there to get all the models straight. But it's there, and we now need kind of acceptance test with DataSite to see if it all works. We kept it really optional because we're testing with millions of records with the ingestion, and we don't want to bombard DataSite with millions of records because for them that's a gigantic amount, and for us it's just 1 or 2 data sets. but all the code has been written and it's just testing now. So this is one piece of the puzzle that we finally think we got right. We can not only do the DOIs and have the DOI infrastructure, and we still did a lot of manual things for the spiders, but we can now also automate this process and get the DOIs into DataSite. So that's a nice step that we took there. Next point is landing pages for source system, mappings, and machine annotation services. And let's go over here, where we changed a couple of things so that you can actually have a landing page. It looks like this for the source system. In this case, it's a bit simple, but there's the mappings and some of the information there. For mappings, I think for machine annotation, it looks a bit nicer with different tabs for the different information there. And it also means that if we direct here in the source system ID, I think this will still go to a handle, and our sandbox and test handles aren't resolving because there are sandbox handles or test handles, but they would redirect to this kind of page. In this case, for the machine annotation, for the minute locality georeference, it would resolve to this page where you can find more information on let's say which container tag is being used, which image is being used. You can find maybe information about code maintainers, about the license. So it would redirect you to this this page. And we also added our first role-based authorization. So before, all these points were behind authentication, but they weren't behind authorization. So this is the point where GRNet comes in. They host this Keycloak for us, which is the identification management tool. I can quickly log in. If it opens, yeah. And show that we now have a role called orchestration. Oh. There we are. That we have a role called orchestration master, admin, orchestration admin. Let's see, orchestration admin, and only if you have this particular role for this client, for the orchestration service, then you'll be allowed to actually create new source systems, new mappings, or new machine annotations. And this became important because the machine annotation services and now the source systems as well, if you add a new one, it will actually push resources to our Kubernetes cluster. So it will create a new application on our cluster. So if this was only about authentication, anybody could register with DiSSCo and start creating these things, which would impact the performance of our servers. So we now put it behind an admin role, which only a couple people have. And so we needed to check how would we implement it in the backends, in the applications. So it's quite a nice first step. Next thing is the integration of the taxonomic resolution service. So here we have let's go to the diagram, taxonomic resolution service. And I showed this last time that we had created this generic, let's see here, this generic component where we would have a name resolution container, which would get a checklist from checklist bank, either the catalog of life or any other checklist, and create an internal data set, which could be called through APIs or through other means. And this worked quite well. We experimented with it a bit, but we had the issue that this DataSite index, especially for the catalog of life, where you're talking about 5 or 6 million records, it took a while to start to index the whole checklist bank data set. And it took quite a lot of memory, so it was quite compute intensive. So we decided to make a split there, where we now say we have a name uses indexer, which does the call to checklist bank, gets the call data package, And this creates an index. It pushes the index to an S3 bucket. So this is a Lucene index, which then can be downloaded by a resolution container, who doesn't need the whole process of downloading the dataset and indexing the whole dataset. It can just download from the S3 bucket the already indexed dataset, pull it in memory, and start running. And this reduced the memory overhead by 3 times, so it's only using a third of the initial memory overhead, and the startup time from about 35 minutes to about a minute to only download this dataset. And the idea is that this can quickly start, so we will probably run it auto-scalable as well, and you can quickly scale up if you want multiple instances. So by decoupling it a bit, you can quickly start and pull it down again. For DiSSCo, we would need to run this name usage indexer one time per month. Each time a new category of life becomes available, we need to run it and then put the latest version on the bucket, and then instruct the name usage resolver to use the latest version. So that's kind of optimization of this process. How it will look like is that we have these translators. They will be triggered. They push to a topic, then the name gets resolved, and that goes to the processing service. And hopefully we can, well, we know there's still gaps in the catalog of life, so that's where the extended catalog of life comes in, which should be there at the end of the year. But for most, I've seen so far, for 99%, we can actually resolve it against the catalog of life name and a full taxonomy. So that means we get a link to the catalog of life identifier, and we get the full taxonomy there. And I'm hoping I can actually demo this. So that's going to be interesting if it actually works. Let's see if I can grab a data set that doesn't have, so for example, this one doesn't have a taxonomy yet. Let me have a look at which source system it's using. So it's using the XMT. It's this source system. And one of the things which is also on the list is that we created a button. We kind of automated the ingestion process. So now by clicking this button, and we can actually have a watch here. We'll make it a bit bigger. Profile presentations. And we'll have it here on the side. It works. Yeah. So if it all works, I will click this button, and then that will trigger the creation of a new, it's called a job, a container on our cluster, which is going to run the ingestion process. So I now selected it. We still need to get some user feedback. And here it is already, the DMC XMT. So that's now starting to run, and that will, you can have a look at it as well, how it's running. That will start ingesting this data set. So this is now persisting data records to database, so follow it, and start publishing those records. So now it's now pushing these records. Yeah, so then now pushed 10,000 records to the whole system, and now we have this application here, which is called the name usage search, and that's being triggered to start resolving these records. So it received a batch of 500 events and processed those. And now, so it's basically each time you see a log message, that's 5,000 specimens that have been resolved against the category of life data set. And they are now being updated. So this one is now auto-scaling, the Kafka specimen processor. It's now still at 0. We'll see if I do it again. Hopefully it's at 1. You can have a look as well. So these are now updating. So because they've been resolved against an actual name from the catalog of life, this means the specimen name has been changed, and we also update the PID record. So these are now being updated. We can have a look at one of them, as it also triggers the processing service. For example, this one has just been updated, and we can go to our Discover platform and check if that's true, if it now contains the full taxonomy. So here we have the full taxonomy in there, and we have an entity relationship to a catalog of life identifier, this specific identifier, which contains additional information. And to prove that this wasn't already there, we also the version 1, and the version 1 didn't contain any identification and didn't contain the link to the catalog of life identifier. So this is, let's refresh it, 1 to 2 back. Yeah. So this is completely new information that we just added by triggering the re-ingestion process. And we now have this component of resolving the taxonomy in the middle there, which resolves against the catalog of life and adds the catalog of life relationship there. So yeah, pretty happy with that part, that it's all working, that it's integrating, that we can actually make the connection to catalog of life. There are still some issues, which actually connected, I think, to the next topic, or is to the rework of the taxonomic filters. The catalog of life does have some things where, let's say, the not complete taxonomy is there, or they have ranks that aren't part of Darwin Core. And I'm guessing these are also things where GBIF, if they're gonna use catalog of life, will run into. So let's see if we can go. The ranks in this case, let's say, I think suborder section zoology isn't, for example, in Darwin Core. Subsection zoology is also not in Darwin Core. So yeah, this is information that we have to drop because we just don't have place at the moment in the Darwin Core model for taxonomy to put this information in. Yeah, that's tricky, and I think that's a part of a broader discussion we might need on how we structure taxonomic information. It could also mean be that, for example, we don't have class, but we only have subclass because this class isn't part of the taxonomy, which makes it hard for taxonomic filters, which I can show here. In search overview, we now have more general taxonomic filters. So if I select one, you can see Kingdom Animalia, and then say, for example, this one. It will, you can drill down to class and all the way to species. But yeah, we probably after this level, we will hit issues because there's some specimens that don't contain class. So we still need to figure out how we handle that lack of parts of the taxonomic tree, because it just isn't as easy as we thought it hoped it would be. But we have taxonomy there, and now it's just figure out these puzzle pieces to also get the whole taxonomic search working. Where was I? Yeah, so scheduling and triggering can also show it in the diagram.
Tom, you would like to comment?
Oh, yeah, Tom.
Yeah, we also added the species name search, so in the taxonomic filter.
Oh yeah, very good. Yeah. So if we have let's see this one, we can actually see it, and you can actually move through as you type the species name. You can move through the list, and will give you the specimen. Yeah, thanks. That's a good addition. Yeah. So it's also with a kind of autocomplete endpoint, and this is based on the species names that we actually have in our system. So it's not based on the species name for catalog of life, it's based on the species that we have in the system as digital specimen. I was opening this part. Yeah. So we did a lot of work on the orchestration services. And the orchestration services, yeah, they're what they call orchestration. And what you just seen is that the orchestration backend actually triggers a translator job, so creates a new instance of this translator. And so this is one thing we really wanted, because it was still a manual action to trigger the translator, and now we can do it through the orchestration front end. Another is that the orchestration front end orchestration services also add these machine annotation services that we saw before. So actually, if we go back to the previous specimen, we still got it somewhere. Well, let's just do it this way. If we grab a specimen, just because I like doing this part, I always like triggering the machine annotation service and then say, well, I want to connect to GBIF as well. This is adding these machine annotation services is also part of the orchestration backend. So this is really a component which kind of has direct access to our cluster and to our compute power, and then is able to add things, add services, which can then be either triggered by manual action by the user. So me selecting, saying I want to run this annotation service over the specific specimen, or it can add things on the ingestion side, say I want to trigger this translation service. If I'm now adding a new translative service, so I'm adding a new source system, a new system which sources information for us, it will also add a cron job to the system, saying each time, and this is a kind of randomized cron job on day and hour, once a week at a random time, I want to run a re-ingestion of this data set. So this is actually, it directly starts ingesting the data set, but it also creates a regular re-ingestion process, which will just in the background start at a random time in the week and start re-ingesting all the data to see if there are any differences. Just to show that we now actually, the machine annotation services are still working. We now have the, need to refresh. We now have, besides the core ID, we also have the GBIF ID. So this creates, the machine annotation service creates a connection to GBIF. And I think this part would be nice to show if I actually add a new data set. So let's go here, we have the source systems. And now I want to add a new data set and already prepared a bit. I want to say the fish collection from München. And I know this is the endpoint, it's a BiCIKL endpoint. So I also say here, it's ABCD. And this is a new mapping we need for this. So Tom also redid this whole interface. And the mapping I'm gonna call the same thing. You can reuse mapping. So for example, for Naturalis, I created one mapping and we reused that for a couple of data sets. So mapping, and we set a default mapping for the organization, where this is the ROR. And I know that the physical specimen type is a locally unique number. And again, we will pick, let's have a watch. This will, creating this new system will I need to move this one. Yeah. Save it. Ooh. I think this might still not work, Tom. Okay, we had a small issue here with the thought we fixed this morning, but now I'm not so sure. I know at least that it works for DiSSCo Archive. I have one prepared here as well, where we actually have this one. This is DiSSCo, and I think that should work. We also create a new mapping, and it's also called the same. mapping, and this is a Darwin core, and the default mappings are this one and this specimen ID type is local as well. Next, save. I just tested this. I'm pretty sure it worked, but it might be a caching issue. Anyway, I can show it here as well. I just did one. Clear this up this morning, and this created a cron job in. So I added this data set this morning. Yeah, this data set I added this morning. So you also see that it has the 7-tree queue, and this is also the 7-tree queue. And this is now, beside that it immediately started ingesting the data set, it also created this cron job, which says each time in the week at 10 on Thursday, so this is randomized, it will start ingesting the data set, this particular data set, and check if there are any differences. So this has also been automated. Yeah, couple other things. We have a configurable MAS timeout. So before, if there was an issue with the MAS and yeah, we wouldn't get any response from the machine annotation service because it crashed or there was some other issue, then your request for the machine annotation service would just hang there. It would stay scheduled for indefinitely. Now, each time a machine annotation service is scheduled, we also added a timeout there and say, well, if I think the default says if it takes longer than I think 1 or 2 days, then we will say we're not expecting a response anymore. But we made it configurable so that each machine annotation service, each of those services can have a configurable timeout and indicate for itself that, you know, some might take longer, some might take shorter. So there could be, you can configure that timeout there. A feature that we're really happy about is we're now auto-scaling our clusters. So based on the request that the application gets in, so for each application that we run, we indicate how many memory and CPU we're expecting. And based on that information, it's either it's scaling or cluster. So there are 2 machines which are continuously there, but the rest is just based on calculation that this tool, Carpenter, makes. And I'm hoping I can also show this in action, but bear with me. So one of the things we know are pretty heavy for our system is the Catalog of Life indexing service. And just to show that it actually works, and we already have quite a good experience on the test environment where it's looking really good. I deployed this Monday on the acceptance environment, and it also looked good. I will deploy a heavy application on the acceptance environment. So that's the name usage search indexing. So we can now check how many machines are actually, it's a bit slow, but how many machines are actually part of this cluster. And that's at the moment we have 4 machines here. And these correspond actually to, if you look in AWS, we see our cluster and the compute. And this is 4 machines, of which 2 are fixed in a node management groups and 2 are scaled based on the requirements that we have. If we now say, well, we're gonna apply a heavy service, name search indexing job, which is really heavy, it will first say here that it's pending. So it cannot find a server on which it can currently run. You can actually see it here saying, well, 0 or 4 nodes are available. So there isn't any space on the cluster, so it cannot run. But if we now check what's happening behind the scenes, and then I'm hoping that it will actually work. I'm hoping that this will go. We see that a new node was added just now, just 5 seconds ago. This tool recognized that we wanted to run something, but there was no space left on the cluster. So it's adding this node, and this is now ready. So the node is ready. And now it says container creating. So it found space on the cluster and is now creating this container. And if you look in AWS, you also see it added this particular node. It was created just a few seconds ago. That's great. So now this large application for which we didn't add any space has now, it decided based on the needs of the application, which type of server it will run. And if this runs a bit longer, it will probably combine 2 machines into one more optimized version, or it will constantly figure out which resources our cluster needs or application needs. And if I now look at this, so it's now running, but yeah, I changed my mind. We don't want this anyway. So now I'm removing this compute heavy job. And what we now wanted to do is in a couple minutes, and I hope I can show you during this demo, is actually scaled down. And often it was quite fast. Within like a minute, it already scaled down. It recognized, well, I have this machine, but this machine doesn't actually have any work to do. So let's remove it because we can do without. It might take a second to recognize, to reconcile and make the calculations. Like, we don't need this machine. And
the screen that you show seems frozen.
Oh, wait. Why? Screen sharing is paused. Why would you?
Maybe stop and reshare.
Yeah, I'm trying now. Stop sharing. Okay. Let's reshare. Yeah, that doesn't help. Okay. Yeah, there we are again. Did you get that the machine was added?
No, we didn't see this.
Okay. Well, we can actually scroll back a bit. So, yeah, when we edit the application, it says there were insufficient nodes because there were only 4 nodes and it didn't fit. Then it actually scaled up a node. So a physical machine on the backend was added. Then the container got created. And now I was hoping that it would scale down and remove this new machine as it was no longer needed because the application is no longer running. And we will see here that we're back to 4. And if we look in the AWS portal, we had this machine, which was created a few seconds ago. We do a refresh here. It's gone because the application is no longer there and the server is no longer needed. So this gives us huge flexibility in only using resources we actually need for our applications. And if we got a lot of ingestion jobs, because we're getting a lot of data in, we can scale up and we can scale down when it's quiet and don't use any unnecessary resources. So this is we're really happy that this works and works so well. One of the things we actually already implemented on our test cluster is that we downsize when we're not in office hours. So we say to a lot of applications, just go to sleep, just scale down to 0. And this will immediately trigger the auto scaling, saying, well, there's we have no need for these machines, so we also scale down these machines. So outside of office hours and in weekends, we scale down the whole system for test. And when we're back in office, we'll scale it up, and you will never notice that anything happened or that we scaled down in weekends or in evenings. So this is also connected to a green IT movement. Don't use any unnecessary resources. Nobody is working on Saturday or Sunday, and we don't need a dev cluster, or at least not the full size of the dev cluster. One more thing before I'll let Tom show a bit of Tetris. We have centralized logging and monitoring. So we put some things in, and let's see. Hopefully, it's still active. And we're using the Elk stack for this because we were already using the Elk Elasticsearch for or applications anyway. Yeah, and I need to renew this connection. Let's see if my token still works. So in the background, we now have a system in place where it's gathering both the metrics as well as the logs from our application. So in this case, we're looking at Java logs. So from our Java applications that are on a level of info. So of our applications, here we see, well, we just ingested some things. So it's saying, well, persisting to Elastic, persisting to database, writing to database, received valid batch update request, so that it's in the DiSSCo handle manager. So this is all the statements that we put in there in the applications, all combined together. We can also easily say, well, now we actually want only warning statements. And if we got errors, we can look at the error statements. And now we'll filter and say, well, we see that the name usage deployment has a block submission because it's a bit throttling if it's on high load. Still something I want to look into. So that gives a warning. It will give a warning when it cannot resolve something. I think they're mainly the same statements. So at least we have more insight in what's actually happening and what info statements, what our application are saying. We can also see access logs, so who's accessing our applications. So be aware that if you're going to make a lot of requests to DiSSCo, we will find you. Let's see if it loads. We will see a lot of activity, which is mainly people trying to break into our cluster. But we have this nice map where you can also see people are making a lot of calls from somewhere near London. This is probably me making calls to DiSSCo. In Denmark, people are making calls. And if you look at what these calls are, they are to the handle manager, to different specimens. Sometimes we get a lot of forbidden calls. Well, this was in the last 15 minutes. We also see people trying to access environmental variables and a lot of hackers trying to get in, but these are mainly response code 200, so these are positive calls to a cluster. And these are specimens that I probably made a lot of calls to because we're showing things. But we also get metrics over what's being used, what kind of browsers, Edge and Chrome, operating systems, how much traffic goes in. So these are now things we're all gathering so that we can have a bit of look and feel who's using the system, how much is being used. And metrics, we got those as well. If we go here, we can see how much memory and CPU and network traffic for all the applications are getting in. So you see we got a lot of applications running, a lot of nodes, and here you can see, for example, for memory, we see that Elasticsearch is using quite a lot of memory, or Kafka cluster, but also the name usage, the DiSSCo name usage. So the taxonomic resolver is using quite a lot of memory. Yeah, you can see per application how much it's using and how much CPU it's using. So we know how much volumes are there, how much pods are running. Yeah, those kinds of things. So this is now more or less in place. This is the first version. We need to see if this provides us with all the information. I hit a couple of things with alerts because if there was an exception, I wanted it to be pushed to Slack. But that was still a bit tricky to do. So we'll see where we end. Yeah, last things. Yeah, as Wouter mentioned, we're completing the BiCIKL 7.4 and the digital object repository. I think it's interesting because it's mainly the storage solution behind DiSSCo. We're finishing up the 3.2 on the collection description dashboards, of which most of you were involved. And we have submitted 2 TETTRIs abstracts, one on the Discover and one on the DOIs. And then Tom, can I keep sharing and you give instructions? That might be easiest.
Yeah, that's okay. Yeah.
Shall I grab the TETTRIs Marketplace?
Yeah, sure. So shortly a bit about TETTRIs. another project we're working on, and it's not really related to DiSSCo, but it's taking a significant amount of our time. So we want to show a bit what we're doing. So TETTRIs is a project which aims to provide services and knowledge for taxonomists to tackle biodiversity loss. And one of these services we are developing under the work package 3.1 in TETTRIs, which is called the Marketplace. I think you need to log out, Sam, because it's a key log issue.
Ah, okay,
Yeah. And the Marketplace is going to be a place where we collect different taxonomic services, and we provide them via, a one-way to taxonomists, so people can find these services. Also included in the portal later on is expertise, which is another task in the project 3.3, which aims to connect taxonomists with each other and let them provide expertise to each other to learn from each other. But mostly we're now aiming on creating the part for the taxonomic services and reference collections. And the reference collections are actually a bridge between DiSSCo and TETTRIs, because in DiSSCo we're also aiming for virtual collections eventually, and these virtual collections will also represent the reference collections. So a reference collection can be a virtual collection. So for example, a reference collection in the marketplace can revert to Discover, which holds a virtual collection. So this way we can still make connections and make it kind of valuable for DiSSCo as well. So what we have been doing is creating we started with the idea, and we had a meeting discussing what we're going to do and what our goal was for June, because in June we have a workshop on this. So we first set up to make some mock-ups of the marketplace, of what we want, collect feedback on those, and create a data model. So currently we have design documents set up with a lot of different versions of this, what you now are seeing. This is the homepage of the application. We gathered some feedback on that and try to make a refined version, which is this one. And in the background, we're working on the data model. So we're trying to align with the DiSSCo Marketplace, which is another very big global marketplace, and trying to use the same kind of terms in a way we can interact or maybe even integrate with DiSSCo at some point. And we're trying to review the data model today even, and see if we can implement it soon. Yeah, and what we now currently have, so we have a first little application which is hosted on by CTEF, because it's a CTEF service officially, with a very simple homepage which you can search and displays the 3 different categories. So some of you would enter a query, because the button doesn't work yet. Just enter something random. It'll take you to the search result page, which now fetches some demo stuff. So this is all fake, but it's just to show off. These should represent taxonomic services in the marketplace, which you can filter through and search, and eventually click on them to trigger, to navigate to the taxonomic service itself. So it's basically a kind of hub marketplace to easily find these services. We're still a bit in debate on how to build the backends. So how are we going to provide these services, and how are we going to interact with an API? So that's still kind of discussion we're having with CTEF. But in the meantime, we will continue with this front end and the data model, and hopefully also create some value for DiSSCo with the reference collections eventually. So that's a little demo of TETTRIs, just to show off what we're spending our time on also. Yeah.
time left because I talked for too long. But looking forward, few things we still have from last time, which is batch annotations. We're a bit further, but we also had a couple issues with, especially in the Minnet locality server. That's a long story. We still need to update the mid calculation. I couldn't get it done at the moment, looking into it. We've spoken to people from Bolt, and they're interested in helping to get a linkage service to Bolt so that we can link specimen from DiSSCo with direct records in Bolt. We want to simplify the annotations, the menu annotations. There are some mockups behind this link if you're interested. Tom is working on mockups and then on implementation. We need to start documenting for supplying data and metadata. Tombstoning is now possible because we have this translated job record, which I didn't got into, but it helps tombstoning specimen records. Of course, further implementation of TETTRIs, and we need to start planning for the create a plan for the MVP, which is the milestone 3.1, and other things that we're kind of looking into is a vocabulary server, improve logging and registration and integration with ORGID. So we want to get a validated connection to ORGID so that you can select it and then attach your ORGID to your user. The virtual collections that Tom mentioned, and we want to start with some end user testing so we can get some actual feedback for the front end and the usability back, so that we can integrate it before we move to an MVP. More the additional resources, and we have got 2 minutes for questions. Are there any remarks? You can always mail or email us with questions or.
Yeah, absolutely fantastic, Sam. I'm totally impressed. Just one question regarding this, and this is probably a minor thing of what you showed, of course, regarding this specimen name completion you showed. I didn't really got it, but it looked a little bit to me like you changed the specimen name to species or genus name SP, which means species. So, for example, if I have Tyrannosaurus rex, I have a determined specimen species. I have a determined species, taxonomic determination on species level. But if I say Tyrannosaurus SP or Tyrannosaurus species, means I have a Tyrannosaurus, and I don't know exactly which species this is, but I know the genus, for example. This is in the level. So question is, would it make sense to have a taxonomist at a certain point to review what you did? Because I think this was done, though you went from a more narrow term determination on species level to a broader match, so to say, something which matches broader, taxonomic, whatever, SP. And probably they're not all synonyms. Likewise, you said you're not using a controlled vocabulary here, but your vocabulary is all the names in the system. Yeah, you want to preserve what is already there, which could be vernacular names of different descendants, so to say, different quality. Maybe it makes sense to have a taxonomist reviewing these things, or?
Yeah, no, definitely. I'm not taxonomist, and I don't have that knowledge in house, and I don't think we have it readily in the team at the moment. So it would definitely be good to have a taxonomist look at this, and we might need to change a couple of things on how we're doing it. So I made a couple of choices just to to get things in, but. And we keep all the initial information. So what we now do is we base the taxonomic resolution based on the information that we have, which is often only the scientific name. And then if we get a positive match, we replace the taxonomic identification with the match that we made. And I now store the provided scientific name in the verbatim identification. But I think you can have a discussion whether you need to remove the old identification and then completely replace it with the resolved identification from catalog of life, or if you need to keep them both, but then say one is accepted over the other. Yeah, I've made some choices now, but we probably need to review those at some point.
I
Yeah.
think we're on the same page here. I think we need external judgment here from taxonomists, because I mean, for us, it's quite impressive what is already achieved and that this recommendation works as it is, but it might be for taxonomists simply be interpreted as a showstopper, and they might focus on that thing because probably when I call names show up. And I don't even know if taxonomists would agree on what the best practice is here, but maybe we need external.
Yeah, so I think that's a bit of the balance. So I think from our side, we think we need to say, well, we resolve against catalog of life and in the future against the extended catalog of life. But we have more room, so we can have multiple taxonomic identifications. So yeah, we can also say we keep the old one as is and just only add one to it and make that the accepted one. But yeah, it's tricky because as you said, there's probably no accepted way to do it. No golden way. But we need that information at some point. But yeah, this is definitely something which, it would be good if we discuss this with users and taxonomists on how would you like to have it? How would you like to preserve the original information?
Yeah, and then I have one more question, which I think goes also to Wouter, or maybe to both of you. I saw these attributes you forward to BiCIKL very early in the first part Wouter presented, and there was among the metadata of the attributes in the PIT record, there was something like FDO record license. I mean, this vocabulary is not standardized yet. Yeah, that's my question. I mean, we made them all up ourselves, or you made them all up yourself. So, I mean, for the digital specimens, this is probably not problematic because DiSSCo is the main authority to issue the standard or the specification, which involves also kind of sovereignty over the kernel attributes regarding to this FDO type. But somewhere, of course, generic, like this FDO record license, for example, what's one I made a note.
Yeah, there are only two elements in the kernel.
Standardized this metadata,
There are only two elements that are currently mandatory, given the definitions of the FDO form, which we both have. So that's the type and the FDO profile.
But I think even these are not, I mean, the vocabulary itself, I mean, how these things are called, even that is not standardized yet.
No, it's not standardized. And I don't think it will ever.
You can change it, of course, and
I don't think it will ever be standardized. There may be some recommendation from the FDO form. So I think we need to have one big revision that we look at what we currently have, see if there is a recommendation for terms to be used by FDO form, and then we can change to that. But we may also have to make our own choices there because, for instance, we use DOIs, so we also would like to be compatible with the standards that the DOI Foundation is using for this metadata. It is not really an issue. I think it's not standardized because these terms are defined in the FDO profile. So you can...
Yeah, and you can update, of course, these PID record very fast. Or I mean, even if FDO would change it, to my knowledge, this is not determined yet. But if it is, I mean, you can more or less instantly change it again, of course, this record. It's not like...
We could change it, yeah. We don't want to do that every day, but we could change it.
No, but in cases metadata is standardized, you might have to touch it, I think, yeah.
Yep.